Dear students, welcome to Tungal online classes. Today we shall start with another interesting chapter of dual nature of radiation and matter. Yes, radiation is nothing but the light or the electromagnetic wave you can consider. Yes, matter is nothing but the atoms you can consider, or in general for our studies we shall consider electrons. Yes. So far in the study of light or electromagnetic wave, yes, we have seen some of the properties, some of the behaviors like polarization, interference, diffraction. All these properties of light have proved the wave nature of the light. Yes, they have proved the wave nature of light. Yes. Similarly, electrons being matters, they behave like matter. Okay. It is interesting to know whether the light also exhibits a particle nature, and if the electron can exhibit the wave nature. Yes. In this chapter, we will understand that both the radiation as well as the matter both exhibit the wave nature as well as particle nature. Yes, there are some properties like photoelectric effect. Yes, photoelectric effect. These phenomena, they will prove the particle nature of the light. Yes, we have Compton effect, we have Stark effect. These phenomena, they will support the wave nature of the light. So these phenomena, along with the Hertz and Maxwell experiments that we have studied in electromagnetic wave chapter, all these they will support the wave nature of the light. Okay, hence both wave nature as well as particle nature of the light is established. Okay, in different conditions they will exhibit both particle as well as wave nature. Okay, in this chapter we are also going to see the electron or the matter also exhibits the wave nature. Hence, both radiation as well as matter exhibit both particle as well as wave nature. Yes. Before getting into details of these experiments, first we shall understand the free electrons and emission of electrons, which will help us to understand the concepts better. Yes. As we know, any atom consists of a certain number of protons and neutrons in the nucleus, and the electrons, depending on their energies, they will be revolving around the nucleus in different orbits. Okay, and the electrons which are in the outermost shells, or these electrons are also called valence electrons. Valence electrons are loosely bound by the nucleus. Okay. When these electrons gain the energy from any other source, they can liberate out of these orbits. Okay, but at the room temperature, if I consider any metal surface like this, the electrons on the metal surface, yes, so which are the valence electrons on the metal surface. So if they get the energy in the form of thermal agitation, so they will try to move out of the surface. But what happens when the electrons move out of the surface? Immediately the surface becomes positively charged. Okay, this positively charged surface again pulls back that electron. Okay, so there is some potential barrier created. Yes, there is some potential barrier created whenever electrons try to move out of the surface by gaining the energy by the atmospheric temperature. The surface immediately becomes positively charged, and that will again pull back the electrons, right? So these electrons should overcome this barrier to escape out of the surface. Okay, so there is some need of energy, they need some minimum energy to escape out of the orbits, so that they will be free from the atom. Okay, so this minimum energy required by the free electrons on the surface of the metal, so as to just escape out of the surface. just to escape out of the surface. This minimum energy required is called work function, is called a work function of that metal. Yes, it is denoted by phi. It is the minimum energy required by the free electrons on the surface of the metal just to escape out of that surface. Okay, if any energy is given in any form which is greater than a work function of that metal surface, then electrons can easily emit out of the surface of the metal. Okay, so this emission of electron from the surface of the metal, that we simply call it as a electron emission. Yes, so whenever electrons, the free electrons gain sufficient energy which is greater than its work function, metal's work function, electrons easily emit out of the surface of the metal. That emission we call it as a electron emission. Yes, then there are different types of electron emission. There are different methods in which electrons can be emitted by the surface of the metal. Okay, the first method of electron emission is thermionic emission. Yes, thermionic emission. In thermionic emission, as the name suggests, the electron emission takes place by the help of thermal energy. Okay, so whenever any conductor is heated, there are different methods to heat the conductor. So when the conductor is heated by passing the current, that example we can take here. So whenever heat is applied to the conductor, the electrons on the surface, they absorb that energy and they will liberate out of the surface. Okay, they will emit out of the surface. Okay, here the emission of these electrons is taking place by the help of heat energy supplied. Okay, such type of electron emission we term it as a thermionic emission. Yes, next we have photoelectric emission. Yes, photoelectric emission. This is a more familiar electron emission. Here also, as the name suggests, the electron emission takes place by the help of light energy. The principle is same. We just want to provide energy to the free electrons, but the form of energy given to the electrons is different. Okay, sometimes we give the energy in the form of heat energy, sometimes we give the energy in the form of light energy, we give the energy in the form of electric field energy, we give the energy in the form of kinetic energy. Okay, depending on those types we have different names, but only intention is to provide some energy to the electrons which is greater than the work function of that metal surface. Okay, so for photoelectric effect, let us consider the light radiation which is incident on the metal surface. Okay, so whenever light radiation is incident on the metal surface, it is having some energy which is given by h into nu. Okay, this h is Planck's constant and nu is the frequency of incident radiation. Okay, so the electron will absorb that energy, and that will emit out of the surface of the metal. Okay, so here the energy is given in the form of light energy. Yes, but the photoelectric emission takes place only if the incident energy is greater than the work function. Okay, so to have the incident energy greater than work function, the frequency should have some minimum value. Okay, so that frequency we call it as a nu naught, we call it as a threshold frequency. Yes, threshold of frequency. Yes, so this is the minimum value of frequency of the incident light radiation on the metal surface, so that the electron emission takes place. Okay, if the frequency is less than threshold frequency, we will not observe any photoelectric emission. Yes, then the work function is different for different metals. Okay, and the work function is measured in terms of electron volt. Yes, that quantity of energy is very small, so we are using the unit of electron volt. Okay, for cesium metal, it is 2.14 electron volt. Okay, For platinum it is a 5.65 electron volt. Okay, so cesium has a very low value of work function and platinum has a very high value of work function. Okay, it means the electron can easily emit out of the cesium metal and it is difficult to emit the electron from the surface of platinum material. Okay, and electron volt, this unit can be defined as it is the energy. This is the energy given to an electron, which is accelerated. Yes, it is the energy given to electron when it is accelerated by 1 volt potential difference. Okay, so whenever the electron is applied with the potential difference of 1 volt, whatever energy is given to that electron, that energy we can term it as 1 electron volt energy. That is very small magnitude of the energy. Okay. Then next method we have secondary emission. Yes, we have secondary emission. In secondary emission, the metal surface is struck by fast moving electrons. Okay, we have the kinetic energy given to the electrons. These electrons are called primary electrons. These are primary electrons. The kinetic energy is supplied to the primary electrons. When these electrons hit the surface of the metal, the electrons on the surface of the metal, they will gain that energy, they will absorb that energy and they will emit out of the surface. Okay, these electrons emitted by the metal surface are called secondary electrons. Yes, secondary electrons. Here the emission of the electrons takes place by primary electrons. Okay, such type of emission in which the electrons are emitted by fast moving primary electrons is called secondary emission. Okay, here we are using the kinetic energy for emission of electrons. Yes, and next we have field emission. Yes, we have field emission. Yes, so here whenever any metal is subjected to very strong electric field, let us consider a metal is placed under a strong electric field. Yes, so we know the electrons in the metal, those are charged particles, those experience some force. Yes, if the electric field is in positive direction, these electrons will experience force in opposite direction. Yes, they are negatively charged, they move in the opposite direction of electric field. Yes, the force experienced is given by F is equal to Q into E. Okay, where Q is a charge of electron. Yes, so in this case, if the force experienced by the charges electrons is very large, easily they come out of a metal surface. Okay, and usually what happens, the electrons which are on the surface, they need somewhat lesser energy than the electrons which are inside the metal surface. Okay, such type of emission which occurs because of the energy supplied in the form of a strong electric field. The range of this electric field is around 10 to the power of 8 volt per meter. Okay, that is the magnitude for emission of electron by electric field. Yes, these are some of significant methods of emission of electrons. Yes. Next we shall study interesting concept of photoelectric effect. Yes, photoelectric effect in detail. Okay, just now as we discussed, photoelectric effect, it is the emission of electrons from the metal surface whenever the light of suitable frequency is incident on the metal surface. Okay, so initially it was detected by Hendrik Hertz. Yes, Hendrik Hertz, when he was working on the electromagnetic waves, he found out the photoelectric effect, and later Halbach and Lenard's experiment further established the photoelectric effect. Okay. So, in the electromagnetic waves, yes, so we have seen the study of electromagnetic waves. Yes. So, here we have the transformer which is connected to AC. Yes. So, he took two metal plates like this, two metal plates P1 and P2 which are connected to small spheres. Yes. So, we observed the sparks in the detector ring here. Okay. So, this is where the spark is generated. Okay. So, here because of charging of these metal plates, there is very strong electric field generated between the spheres S1 and S2. Okay. So, this will produce the spark, which in turn produces the magnetic field in a horizontal plane. Okay. So, here we have S1 dash and S2 dash. Okay. This need not be explained in detail, just we want to know how Hendrik Hertz came to know about photoelectric effect when he was studying about electromagnetic waves. Okay. Because of this strong magnetic field, again there is EMF induced between this S1 dash and S2 dash spheres. So, here also the sparks are induced. Okay. And he observed the sparks were readily generated, right? High voltage sparks were easily generated when these metal plates were incident by ultraviolet radiations. Okay. So, whenever there is no ultraviolet radiation incident on the metal plates, then also there are high voltage sparks, but there are more enhanced high voltage sparks were produced between the spheres S1 dash and S2 dash when these metal plates were incident by the ultraviolet radiations. Okay. So, by this he concluded that the ultraviolet radiations which are incident on the metal plates P1 and P2, they provided more number of free electrons. Okay. So, that further increased the value of voltage between S1 and S2, hence stronger magnetic field, and hence high voltage sparks were readily available between S1 dash and S2 dash. Okay. So, this is the observation made by Hendrik Hertz. Okay. So, he was the first one to introduce the photoelectric effect. Yes. Then we have Halbach and Lenard's experiment, which easily proves the photoelectric effect. Okay. So, for that what they did is they considered a negatively charged zinc plate. Yes, they considered negatively charged zinc plate. Yes, let us consider this is completely negatively charged. Okay. This negatively charged zinc plate, this was connected to electroscope. Yes, gold leaf electroscope here. Yes, let us consider a simple gold leaf electroscope. Yes, this is thin spindle. Here we have thin gold foils like this. Okay. So, whenever this zinc plate was completely charged with negative charges, there was more deflection. Okay, there was more deflection of these gold leaves. Yes, as we know, when this plate is negatively charged, these more number of electrons, because when it is negatively charged, it is having excess of electrons. Okay, these excess of electrons, they will move towards the gold foils. Okay, so on both the gold foils, there is accumulation of negative charges. Hence, there is repulsion, there is deflection of gold leaves because of repulsion. Both are negatively charged, so they will move away from each other. Okay. So, when the charge was more, when the negative charge was more, the deflection was also more. Okay, initially. Then, when the incident the ultraviolet radiations, on the negatively charged zinc plate. Yes, observe here the incident, the ultraviolet radiations on the negatively charged zinc plate. These electrons on the metal surface, yes, So when these ultraviolet radiations hit the surface, when they hit the surface, the electrons on the surface, they absorb that energy, and they emitted out of the metal surface. Okay. Then now what happens when some of the electrons, they moved out of this negatively charged zinc plate, the negative charge reduces. Yes, what happened here? The negative charge of a zinc plate that reduced. Okay. So when the negative charge reduced, the electrons which are accumulated in more in number here, some of these electrons again they moved back to zinc plate when the density of the electrons reduces. Yes, automatically these electrons which are very high in number here, so the charge density is more on the gold leaves. So those electrons they will again move back to zinc plate. Okay. So when the charge density is reduced, automatically the repulsive force between these gold leaves reduced. So the deflection of the gold leaves also reduced. Okay. I repeat again here. So when the charge was more, when the negative charge was more on the zinc plate before the incidence of ultraviolet radiations, some of these electrons they accumulated on the surface of gold leaves. Okay. So which increased the repulsive force between these gold leaves. Okay. What happens when the ultraviolet radiations are incident on the zinc plate, right? So the electrons on the surface of this negatively charged zinc plate, those electrons they absorbed that energy and they left the surface by the electron emission. Okay. So when the number of electrons is reduced on the zinc plate surface, so the electrons which were accumulated on the gold leaves of electroscope, they again moved back to the zinc surface. Okay. Hence the repulsive force between these two gold leaves reduced, so their deflection is also reduced. Yes. So by this observation they concluded that whenever the light radiation is incident on a metal surface, there is emission of electrons. Yes, this is a very nice example that proves the establishment of a photoelectric effect. Yes, the figure shows simple schematic experimental setup to study the photoelectric effect. Okay, it consists of an evacuated glass tube or a quartz tube which encloses two plates here. Yes, one is emitter plate E and another is a collector plate C. Okay. And this collector plate is made anode by connecting it to the positive terminal of the battery. Okay. And it is connected through a micro emitter that measures the photo current through the circuit. Okay. And this collector plate is connected to the negative terminal, so this will act as a cathode. Okay. Then we have a source of monochromatic light which sends the light radiations on the metal surface here. Okay. So this will act as a source of monochromatic light radiations. Yes, and these radiations will pass through a transparent window here. Okay. This is about the simple construction of photoelectric experimental setup. Okay. Then how it works that we can see here. So whenever the light radiations by the source of light are incident on the emitter surface, this metal surface E, what happens? The electrons on the metal surface, these electrons on the metal surface, they will absorb that energy and they will emit out of the surface. Okay. But they are free to move anywhere they want. But here what we do here, we will connect this collector plate to the positive terminal. So this positively charged collector plate which acts as a anode, this will absorb the electrons towards it. Okay. How many electrons will move towards this collector plate, that depends on what is the potential present on the anode plate here. Okay. So if the potential is more, automatically more number of electrons get attracted. Okay. So electrons will move towards the anode here and they will move through the circuit. Okay. And the magnitude of this electric current created by the motion of these electrons, that is measured using a micro emitter. Okay, this is how the photocurrent is produced by the help of photoelectric effect. Okay, and this experimental setup is used to study the effect of important parameters such as the intensity of the incident light radiation, the frequency of the incident light radiation, and the potential difference between this cathode and anode. Yes, so this potential difference between collector and emitter plates. Yes, then the nature of surface of this emitter plate. Yes, the nature of surface of the emitter plate. All these effects, because of these parameters, can be studied by this experimental setup. Okay, one by one we shall study in detail. First, we shall study the effect of intensity of incident light. Yes, intensity of the incident light is nothing but the number of light radiations falling on the surface by the source. Okay, if the intensity is more, it is understood that more number of radiations are emitted by the source and more number of radiations are falling on the metal surface. Okay, for studying the effect of intensity of incident light radiation, we have to keep the frequency of the light radiation constant. Okay, frequency has to be constant and the potential of this anode should also be constant. Okay, so we are keeping the frequency constant and also the potential is also constant. Okay, then only we can understand the genuine effect of the intensity of incident light radiations. Okay, and we are also keeping the frequency of the incident light radiations greater than the threshold frequency. Okay, then only we can observe the photoelectric effect. Okay, so now having all these conditions, when the intensity increases, I will plot the intensity along x axis and the photocurrent along y axis. Okay, when the intensity increases, more number of radiations are falling on the metal surface, and as we know, all the radiations have frequency greater than threshold frequency. Okay, so these more number of radiations will make the more number of electrons to get emitted out of metal surface. Okay, when more electrons are emitted, automatically the reading in the micro emitter also increases. That states that the photocurrent also increases. Okay, I repeat again, as the intensity is more, the number of radiations falling on the metal surface is also more, the number of electrons emitting out of the surface is also more. When number of electrons are more, automatically the photocurrent through this closed circuit is also more. So the photocurrent is observed to be directly proportional to the intensity of incident light radiation, provided the frequency of the light radiations is greater than the threshold frequency and the potential of the anode is kept constant. Okay, this is the effect of intensity of light on the photocurrent. Yes, next we shall study the effect of potential of anode with collector plate. Okay, so for this we shall understand how the current flows through the circuit because of the potential of the collector plate. Yes, so here when the light radiations fall on the surface of the emitter, that is the cathode plate here, these electrons, when they emit out of this metal surface, they are free to move anywhere. Okay, but here what we are doing, we are providing the positive charge on this anode. Yes, positive charge on the collector plate. This positive charge attracts these electrons. Okay, how many electrons are attracted towards this positive plate, that depends on what is the potential on this collector plate. Okay, if the potential is more, more number of electrons are attracted. If the potential is less number of electrons are attracted. Okay, but for that also there is some limit, because the number of electrons is limited. Okay, so maximum we can have all the electrons reaching this collector plate. Okay, at that point the current through this micro emitter, that will be saturated. We cannot have current more than that, because the number of electrons emitted, that depends on the number of radiations which are having the higher value of frequency than the threshold frequency. Okay, I repeat again here, the number of electrons reaching this collector plate, that depends on what is the potential of this collector plate. Okay, the more value of collector plate potential will attract more electrons. Okay, but there is limit for the number of electrons emitted. Yes, so the current in this circuit, that is having some saturation value. Okay, if we increase the value of anode potential, more number of electrons are attracted out of total emitted electrons. Okay, so maximum we can have all the emitted electrons can be made to move towards this collector plate by providing a maximum anode potential here. Okay, beyond that, even if we increase the value of potential, that is useless, because we don't have any extra electrons than that. Okay, so the current value is limited. Okay, then what happens when this anode potential is 0. Okay, so if the anode potential is equal to 0, let us observe there are certain number of electrons emitted by this emitter plate. Okay, out of these emitted electrons, they will move in random directions, and some electrons may move towards this collector plate. Okay, even though the collector plate potential is 0, some electrons may move towards this collector plate, so we will have some finite value of current. Okay, but that will not be equal to 0. Yes, so when the potential on this collector plate is 0, we will have some very small value of finite value of current. Yes, so when the potential is more, there is more value of current. Current increases with the anode potential. Okay, then we shall understand when this collector plate is made cathode. Yes, when it is made cathode here, so what happens? This will be negatively charged. So when this plate is negatively charged, it starts repelling the electrons. So as this negative potential increases, the repulsion of these electrons from this collector plate increases. Okay, as the repulsion of collector plate increases, the electrons move in different directions, which will reduce the value of photocurrent. Okay, so if I want to have zero current, I don't want to have any current, for that this negative potential should be increased to more value here. Okay, so that value of negative potential which should be applied to the collector plate to stop the electrons reaching this collector plate is called stopping potential. Okay, all this concept we shall understand by the help of a graph here. Yes, so let me consider the intensity of the light radiation constant. Okay, so here we should have the intensity is constant. Yes, then let me take along x axis I will plot the potential. Okay, I will plot the potential. Along y axis we shall plot the photoelectric current. Okay, see here, when the collector plate potential is equal to 0, we have some finite value of current. Okay, we have some finite value of current, and here we are also considering frequency is also constant, and frequency is greater than threshold frequency. Okay, then so when our potential is equal to 0, we have some value of current. So that value of current, let it be O to E. Okay, then if I increase, let us again first consider this collector plate is positive. If I increase the positive potential of this collector plate, more number of electrons are attracted towards the collector plate, hence we will observe the increase in the current. Okay, so here we will have there is a increase in the current, something like this. Okay. So here, as the value of positive potential increases, initially the current is increasing, but beyond certain value of this current, this is a saturation current. Okay, this is a saturation current, because at this point of the positive potential of collector plate, all the electrons are attracted towards the collector plate. Okay, we cannot have more number of electrons than that. So this is the maximum value of current that we can obtain here. Okay, so this is a saturated value of current. Yes, similarly, now what happens if the potential is made negative? Okay, if this is connected to the negative terminal, if I reverse the connection here, if this collector plate is made negative, what happens? The electrons which are trying to move towards this collector plate, and these electrons will have some kinetic energy. Okay, so that kinetic energy is given by the light radiations. Yes, so different electrons will have different kinetic energy. The electron which is on the metal surface, exactly on the external surface of the metal, that will have maximum energy, because it needs less energy to come out of the metal surface. Okay, and some electrons which are comparatively inside the metal surface, they will lose some energy. Okay, actually energy given to the electrons is same, but those electrons which, when they are passing through the conductor, when they are passing through the metal, they will lose some energy. Okay, so these electrons have different values of kinetic energies. Okay, so when the negative potential is applied to the collector plate, these electrons, they get repelled by the negative plate. Okay, so gradually what happens, as I increase the value of negative potential, which I am showing it along a negative x axis, gradually the current value decreases. And certain point, for certain value of this negative potential, that I write it as Vs, is for this value of a negative potential, we observe the current is equal to 0. Okay, so to stop the electrons reaching the collector plate, we have to apply some negative potential. Okay, so this negative potential which stops the electrons reaching this collector plate, or which makes the photoelectric current 0, is called the stopping potential. Okay, so this is called stopping potential. Okay, so this is the minimum negative potential, to be applied to collector plate, to stop the electrons reaching the plate, or make photoelectric current 0. Yes, it is the minimum negative potential to be applied to the collector plate to stop the electrons reaching the collector plate, or to make the photoelectric current 0. Okay, so this negative potential is called stopping potential. Okay, and now this is for a given intensity of the light radiation. Okay, if we have different values of intensities, if the same experiment is repeated for different values of the intensity, so then what happens here? Let us consider some 3 values of intensities. Yes, let us consider this is I1, this is I2, and this is I3. Okay, for given value of the intensity, the behavior is same, but we can observe if I3 is greater than I2, that is greater than I1, we can observe the currents observed for higher values of intensity is more. Okay, so I3 is more, hence the current values for I3 are more. Okay, I2 is somewhat lesser, the current values for I2 are lesser, and I1 is the minimum of all these currents. Hence, so this is the minimum intensity of all these 3. So current values for the I1 is less. Okay, but observe the stopping potential here. For all the values of the intensities, the stopping potential is constant. Yes, why that happens like that? Because see here, so this the stopping potential actually depends on what is kinetic energy possessed by the electrons. Okay, so if I consider some value of stopping potential, at stopping potential none of the electron is reaching the collector plate. Okay, so actually these electrons have different values of kinetic energy. Okay, the electrons which are on the surface of the metal, they will have more kinetic energy because they need some less value of energy for emission. The remaining energy is converted into kinetic energy, and relatively the electrons which are inside the metal surface, they have lesser value of kinetic energy, because even though the energy is given same, they will lose some energy to come out of that metal surface. Okay, so by this we should understand that these electrons have different values of kinetic energy. Okay, but at the stopping potential, even the fastest moving electron is not able to reach the collector plate. Okay, so by providing the negative potential or the stopping potential, we are applying some repulsive force. Okay, so the energy required for that repulsive force is nothing but E into Vs. Okay, so this is the stopping potential and E is a charge of this electron. Okay, so the energy to be applied to provide this stopping potential, this is equal to the maximum value of kinetic energy possessed by the electron. Okay, when this value is equal to maximum energy of kinetic energy of the electron, none of the electron will reach the collector plate, hence the photoelectric current will be equal to 0. Okay, so I can write E into Vs is equal to half into m into V maximum square, where V maximum is the maximum velocity of the fastest moving electron. Okay, then so by this we observe that the electrons may not have same value of kinetic energy. Okay, and here we are considering the maximum value of the velocity of fastest moving electron. Yes, based on that we are calculating the stopping potential to be applied to get photoelectric current 0. Yes, then another observation that we can make here is the stopping potential is independent of the intensity of the light radiation. Okay, so we can observe for different values of intensities I1, I2, I3, we have different values of current, but when we observe the stopping potential for these different values of currents I1, I2 and I3, all these stopping potentials are same. Okay, so by this we can say that the stopping potential is independent of, independent of intensity of the incident radiation. Okay, intensity of light radiation. Okay, so here actually the stopping potential is dependent on the energy. Energy is again dependent on what is the frequency of light radiation and what is the nature of the surface. Okay, nature of the surface means the work function of that metal surface. Okay, the stopping potential will be more if the kinetic energy is more. Kinetic energy will be more if the frequency of the incident radiation is more. Okay, and it will be inversely proportional to the work function. Okay, if the work function is more, automatically the kinetic energy reduces. So kinetic energy depends on what is the work function of emitter plate and what is the frequency of the light radiation incident on the metal surface, but it is independent of the intensity. Intensity is just number of light radiations. Okay, it will increase the current, but it has got nothing to do with the stopping potential or kinetic energy of the electrons. Okay, so by all these things we have two conclusions here, that the electrons they do not have the same value of kinetic energy. Okay, then the intensity has nothing to do with the stopping potential, that is the stopping potential depends on the frequency of the light radiations, the nature or the work function of the metal surface, and it is independent of the intensity of light radiations. Yes, so this is how the potential affects the photoelectric current. Yes.